this problem is basically investigating if we understand the concept of integration with estimation of rectangles. And so when you look, it says figure 1 shows part of the graph of y equals 1 over x. Okay, so this curve here is 1 over x, together with line segments parallel to the coordinate axes. Okay, so these are just parallel to the y-axis, these are parallel to the x-axis. It says by considering the areas of appropriate rectangles, show this. Okay, well, kind of things you can surmise here. Natural log is the integral of 1 over x. I have some rectangles that are above that, and I have some rectangles that are below that curve. So what I'm going to do is just start with the fact that I have the integral of 1 over x, and here it would be from a minus 1 to a plus 1. Okay? And so if I look at that quantity, I can see that I'm bounded above and below. Okay? So let's look at what I would be squashed in between. Okay? So if I want to look at what's below, I would be looking at this rectangle and this rectangle. Well, this distance, a minus 1 to a, would be a distance of 1. And from a to a plus 1 would be a distance of 1. When I look at how high it is, it's however high I am at the right endpoint. Okay, so when I look, this would be 1 wide, this first rectangle, and then how high it is would be how high I am at the right endpoint, f of a, however high the function itself is at f of a. So 1 times f of a. And then this other rectangle is also 1 wide, and then how tall it is how tall it is on the right-hand side, which is f of a plus 1. Okay, and so that's something that's lower than it, and then what I'm going to go for is the larger rectangles are certainly above. So if I look at these whole things, that area would be higher than the area under this curve. Okay, again, these are still 1 wide. Okay, so this one would be 1 wide. How high this first rectangle is how high it is going up to here, how high it is the left-hand endpoint. So that would be f of a minus 1. The other one, the rectangle is also 1 wide. How tall it is how tall it is right here, f of a. Okay, so I've got a little bit going on now. I've got it bound between two things. Now, since we know that this function is 1 over x, then how tall it is at f of a is 1 over, just put in a. So this would be 1 over a times 1. 1 times 1 over a plus 1. Similarly, over here, 1 over a minus 1, 1 over a. The integral of 1 over x is really easy. It's just ln of x. It would be the ln of the absolute value of x. I do see, however, that I already have positive x values, so I don't have to write the absolute value if I know that my x's are positive in the region that I'm talking about. And I want to evaluate this from a minus 1 to a plus 1. And so here, if I do that, it would be ln of a plus 1 minus ln of a minus 1. And that, since I look at what they want me to get, when we have spread out subtraction, that turns into division. That would be ln of a plus 1 over a minus 1. Now, as far as what else they want me to get, it kind of looks like I can just get a common denominator between these two. So that's what I'm going to go for. My common denominator would be a times a plus 1. And on this side, it would be a times a minus 1. And on this first term, I'm missing an a plus 1. So multiply the numerator and the denominator times a plus 1. So I would have a plus 1. And this one, the numerator and the denominator need to be multiplied by a. So plus a. So I would have 2a plus 1. And let's just look, they've left that factored, over a times a plus 1. Over here, similarly, I'm missing an a. And on this one, I'm missing an a minus minus 1. So here I would have a plus a minus 1, or just 2a minus 1. And it does appear that I have shown what they wanted me to show. Okay, so that's the first part. Then it says, hence, so using what I just did, find lower and upper bounds for ln of 1.2. Well, basically, this would be 1.2, then this could be an upper bound, and this could be a lower bound. So what I want to do is just figure out what would a have to be for that to be 1.2, and then I can just substitute it into the upper bound and the lower bound. So I would like a plus 1 over a minus 1 to be equal to 1.2, and then you can just multiply both sides by a minus 1. So you would have a plus 1 equals 1.2 times a minus 1. A plus 1 equals, distribute, 1.2a minus 1.2. And you can add the 1.2 over there and get 2.2. Subtract the 1, get 0.2a, and then divide by 0.2, and you would have a is 11. Okay. And so then once you know that, just put in 11 into your upper bound and your lower bound. So your lower bound would be 2 times 11 plus 1 over 11 times 11 plus 1. So 23 over 11 times 12. 23 over 132, and then your upper bound, go over here, 2 times 11 minus 1 over 11 times 11 minus 1, so 21 over, this is 11 times 10, so 110, and so we have conquered that part. Finally, it says an improved upper bound can be found by considering figure 2, which again shows a part of the graph of y equals 1 over x. By considering the areas of appropriate regions, show that, well, this looks suspiciously like what we already did, is less than this. So basically, they want us to show that the area under the curve, y equals 1 over x, would be less than the area of this trapezoid. So they've just changed it to a trapezoid for us. So really, if we knew how to do the first one, we know how to do this one as well. So if we just take a look, we can just say, let's just go ahead and show them one more time. We kind of already did it, but this time it's from a minus 1 to a. So we know that that area under the curve of 1 over x, because that's our function, is going to be less than the area of the trapezoid. And so we already know when we integrate this that it's going to be ln of x. And again, we've kind of already shown this is ln of a minus ln of a minus 1, or just ln of a over a minus 1. Okay. And then the area of this trapezoid, so I mean, you can divide it up a rectangle and a triangle, or you can do 1/2 the height times the sum of the bases. That is under prior learning on your formula sheet, by the way, if you forget it. Okay, so if we look at this, the bases are the ones that are parallel to each other. So that's this and this are your two bases. Doesn't matter which is which. And the height is the perpendicular distance between them. Okay, so from a minus 1 to a, that's just 1. And so that's what I'm going to put in for the height. And then one base would be how high they are at a minus 1. So f of a minus 1. And the other base is how high at f of a. And again, half times 1 is just a half. This is substituting into the function 1 over x, so 1 over a minus 1 plus 1 over a. And hopefully that's just going to turn into this, right, what we already had. So don't really have to worry too much here. We'll leave the half, get a common denominator. This guy is missing the a. This guy is missing the a minus 1. So I would have a plus a minus 1. So you'd have 2a minus 1, and this 2 is just multiplied in the denominator. And we've got that. The last thing it's asking for, so we showed that, it said hence, so using what we just did, find the upper bound for ln of 1.2. And notice, even if you couldn't do that, you could see what they did. Well, know that you want that to be 1.2, figure out what a is, and here will be your upper bound. So always look, hopefully you can do it all, but if you can't, are there some parts that they've kind of given you a start on that you could do? So I would like a over a minus 1 to be equal to 1.2. So you would have multiplying both sides by a minus 1. So you would have 1.2a minus 1.2. And then you could subtract the a, so you'd have 0.2a. And then over here, add the 1.2. Divide by 0.2, you get a is 6. If you want that upper bound, just substitute a into that. So the upper bound would be 2 times 6 minus 1 over 2 times 6, and then 6 minus 1, and that'll come out to be 11 over 60.